Okay, let's make a start. So we've got something like this. You want to expand p plus q to the power of 5. Okay. Has anyone managed to do it? Okay. What do you get?
I got p to the power 5.
Yeah.
Plus 5 p to the power 4q.
Yeah.
Plus 10 p to the power 3 q to the power 2.
Yeah.
Plus 10 p to the power 2 q to the power 3.
Yeah.
Plus 5 p q to the power 4.
Yeah.
Plus q5 q to the power 5.
Well done. And was that? Did you use sort of Pascal's triangle, or did you just expand it out? All right. Did you just expand out the 5 brackets?
Oh yeah, that is squared.
Yeah.
I times it by twice. I got p plus q to the power 4.
Okay. All right. Excellent. Well done. Okay. Now, one of the things. Excuse me. One of the things that we can see from here is this pattern of. If you look at the coefficients, you've got 1, 5, 10, 10, 5, 1. Sorry. Okay. So there's the pattern for the coefficients. And there's another pattern. It's to do with the indices. Can anyone see that pattern? They add up to 5. So 4, so 5, and you've got 4 and a 1, which is 5, 3 and a 2, which is 5, 2 and a 3, which is 5, 1 and a 4, which is 5, and then a 4. Okay? Now, one of the things you'll find, does anyone recognize these numbers? 1, 5. Right, 1, 5, 10, 10, 5, 1. Right. What is Pascal's triangle? Yeah. How does it work? So 1. Yeah.
Then 1, 1. Then
Yeah.
1, 2, 1. Then 1, 3, 3. No, 1, 2, 1.
1, 2 plus 1 gives us 3. So that's a 1. 2 plus 1 gives us a 3. And then you got a 1. Okay. Then 3 plus 1 gives us the 4. 3 plus 3 gives us 6. 3 plus 1 is a 4. And you got a 1. But we haven't come across this line yet, the 1, 5. Alright, then you got 1. 4 plus 1 is a 5. 4 plus 6, 10, 10, 5, 1. Now, let's just be very clear about this. Can everyone make sure you get this? Can you look up, please? Alright, let's just be very clear about this. For this one, the power of the bracket is what? 5. If you count down, n equals 4, n equals 3, n equals 2, n equals 1. So when you start counting the line on Pascal's triangle, it has to start from 0. Okay, you don't start from 1, you start from 0. Okay, and then the 5th line, for the 5th power, you'll be using the 5th line. And those coefficients will give you 1, 5, 10, 10, 5, 1. Sorry? Right, the way to get this number is to add 2 numbers above it, 4 plus 1. 4 plus 6 will give us the 10. 3 plus 3, for example, gives us the 6. 2 plus 1 gives us the 3. 1 plus 1 gives us the 2, and so forth. It starts off. It just starts with 1 and 1, 1. And then it just carries on. Yeah, it's just... Okay. All right. All right. Let's now. It will help if you don't talk when I'm talking. So either you talk or I talk, one of us. All right. Let's now move on to actually try and use this triangle, Pascal's triangle, to actually do an example. So you need to make sure you copy this down. And what we're going to do is expand x plus 2 to the power of 6. Now, if I look at Pascal's triangle for n equals 6, we should get 1, 5 plus 1 is 6, 5 plus 10 is 15, 20, 15, 6, and 1. So I've got these particular coefficients, 1, 6, 6, 15, 20, 15, 6, and 1. What we're then going to do is, I can see, please listen very carefully, we're then going to do is, I can see I've got two terms, x and 2. Okay. What I've got is x, I'm going to start off with the power 6 and 2 to the power of 0. Plus, and then I'm going to start decreasing the powers, so x to the power 5, 2 to the power 1, and increasing the power of the other term next to it, and then plus x to the power of 4 times 2, you see what's going to happen, plus x to the power of 3 times 2 cubed, and then x squared times 2 to the 4, x to the power 1 times 2 to the power 5, and then finally x to the 0 times 2 to the 6. It's good to use brackets, especially when you have a negative number, because that will cause all sorts of problems for you if you don't use the brackets. Okay. Let's now also add some coefficients. So you've got 1, 6, 15. So I can put my 1, 6, 15, 20, and then 15, 6, and then a 1. Okay, and that will give me all my method marks that I need. Okay, what I could then do is tidy them up. Obviously, you wouldn't get a number. I think in a non-calculator question, you wouldn't get numbers that are too fiddly or too big. But if you tidy that up, that should give you x to the 6 plus 2 times 6 is a 12, x to the 5 plus 2 squared is 4, 4 times 15 will give us 60, x to the 4 plus 160 x cubed plus 240 x squared plus 192 to the x plus 64. And so just by using Pascal's triangle, and just by using the fact that the powers add up to the same number, we can do this expansion, Adi, without actually writing out x plus 2 6 times. Okay? And it can also help out. Pretend I gave you x plus 2 to the power of 60, and I said work out the first 4 terms. Okay? Then again, that's something that will be really useful. So what I'd like you to do once you've done that is, once you've copied that down, can you have a go at this question here? Let me just put this in. Can you expand this out fully? So in the future, when you get big powers, I won't say do it fully, I'll just say, well, give me the first 3 or 4 terms. But for this one, example 3, can you work out the full expansion using Pascal's triangle?
When you say 3 or 4 terms, what do you mean?
Like, so x to the power of 6, 12x to the 5, 60 to x4 is the first 3 terms. Yeah, so in the future, I might just say, just give me the first 3 terms, rather than do the whole expansion. But we'll come on to that. But at the moment, let's look at first 4 terms. start by going over it. Okay, so we've got n equals 4. Yeah, we can see that from here, Jan. We've got n equals 4. And then from n equals 4, we can see that the Pascal's triangle gives us 1, 4, 6, 4, 1. So if we write that out, the coefficients are 1, 4, 6, 4, 1. And then what we want to do is take each term and use brackets this time. It's really essential because we'll be taking powers, so put the minus 3y in a bracket as well. Okay, and so that's the first one. And we know, because it's to the power of 4, the 2x is going to be to the power of 4, and the minus 3y is going to be to the power of 0. Okay, and then we've got the 2x to the power of 3, minus 3y to the power of 1. And remember, these powers do need to add up to 4. Yeah, they always add up to 4. 1 goes down, 1 goes up. And then let's also do another one. So you've got 2x, can you quiet down please, squared minus 3y squared plus 2x to the power of 1 minus 3y cubed plus the 2x to the power of 0. I'm putting that naught in deliberately, just to emphasize that it's always there, and you know, 1 goes up, 1 goes down, and you start from 0 and go all the way up to 4. Okay, now we can also add our coefficients, so I can put an equal sign. So this equals, let's put 1, 4, 6, 4, and then the 1. Okay, now this is where the bracket is essential, because obviously it's minus 3 to the power of 1 is still minus 3, but minus 3 squared is then going to give us 9, whereas minus 3 cubed would then give us minus 27. Okay, so that's why the plus sign business is really important. If you were to tidy that up, you should get 16x to the power of 4 minus 96x cubed to the y plus 216 x squared y squared minus 216 xy cubed plus 81 y to the 4. Okay, make sure you do that. It might take you maybe 1 or 2 times, but the point is, because you've got a minus sign, because you've got a coefficient in front of the x, in front of the y, it's very good practice to then start doing the powers of them, and just to make sure, you know, you're working out, you know the maths, it's just you're working out is contains as little errors as possible, and that comes just through lots of practice. Is that okay? Any questions? Hands out if you managed to get that. Well done, excellent. Okay, so a good couple of people in the classroom have done it. Alright, so what I'd like us to do then is to do question 1, level 1.